Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709, Pure Mathematics 3. So, today we will be discussing the exam paper May June 2022, paper 32. Okay, so let's move to question number 1. Solve the equation ln e to the power 2x plus 3 equals to 2x plus ln 3, giving your answer correct to 3 decimal places. Okay, so the first step in this equation would be to collect all the ln terms on one side. Okay, so ln e to the power 2x plus 3 minus ln 3 equals to 2x. Then using the laws of logarithms, we can write them into a single logarithmic function. Now we know that ln is basically log to the base e, right? So that means that I can say that e to the power 2x is equal to this expression. E to the power 2x is equal to e to the power 2x plus 3 divided by 3. So now we'll multiply this 3 to this side. So we have 3 e to the power 2x equals e to the power 2x plus 3. Then 3 e to the power 2x minus e to the power 2x equals to 3. 2 e to the power 2x equals to 3. We'll divide both sides by 2. E to the power 2x is equal to 3 upon 2. Now we will take ln both sides. So this becomes ln e to the power 2x equals ln 3 upon 2. Using the power law, this 2x can be multiplied over here. So 2x times ln e equals ln 3 upon 2. Ln e is basically equal to 1. So therefore, now we can divide both sides by 2. So x is equal to ln 3 upon 2 divided by 2. Okay. So if the question would have asked you to leave this in exact form, we would have left it in this form. But it asks you to give your answer to 3 decimal places. So we will calculate this. So we have ln 3 divided by 2 divided by 2. So that gives us 0.203. All right. Question number 2. Solve the equation 3 cos 2 theta equals 3 cos theta plus 2. Okay, so we have 3 cos 2 theta. Okay, let me bring all of this to the left hand side. Minus 3 cos theta minus 2 equals to 0. Okay, now we know that there are 3 different forms of this double angle formula. Okay, so we know that cos 2 theta is equal to 2 cos squared theta minus 1. We know that cos 2 theta is equal to 1 minus 2 sine squared theta, and we also know that cos 2 theta is equal to cos squared theta minus sine squared theta. Now how am I supposed to know that which form am I supposed to use here? Now just imagine that if you were to plug in any one of these, would your equation become simpler or more complex? Okay, so let's think about it. If I were to put the first one, okay, into this expression, if I substitute cos 2 theta with 2 cos squared theta minus 1, then what would have happened? I would have got a disguised quadratic equation, right? And everything will be in terms of cos theta. So this will be in cos theta, this will be in cos theta. So that means that if I plug in this form, my equation will become simpler. All right, let's try the other ones. If I would have plugged in this value, okay, or this, this expression, I would have got one of my expression is cos theta, the other expression will be sine squared theta. So that's going to make things complex, right? Because now within one equation, you have two different trigonometric ratios. And the same goes here as well. You have cos squared theta, you have sine squared theta, and on top of that, you also have cos theta. So you see, if you plug in the second and the third one, it will become more complex. So that's how you decide. So I'm going to plug in the first one into cos theta. So I'm going to write here 2 cos squared theta minus 1 minus 3 cos theta minus 2 equals to 0. 6 cos squared theta minus 3 cos theta minus 2 equals to 0. 6 cos squared theta minus 3 cos theta minus 3 minus 2, that will be minus 5 equals to 0. So the factors that we need are of 30. Okay, 6 times 5, that will be 30. So we know that 1 times 30, that's 30. 2 times 15 is 30. 3 times 10 is 30. And 6 times 5 is 30. But none of those factors will give you a minus 3, right? The sum of those factors will not give you minus 3. So that means that we have to use quadratic formula. So I'm going to write cos theta equals minus 3 cos theta plus minus. So what is the quadratic formula? X is equal to minus b plus minus b square minus 4ac divided by 2a. So again, minus 3 cos theta whole square minus 4ac. So a will be, sorry, my bad. We're not supposed to write the variables, are we? So here I'm just going to write minus 3 plus minus 3 whole square minus 4ac divided by 2a. Okay, so from here we will get two expressions. So this becomes 3. Then we have 3 plus. Now if I work out the root of this, so that will be square root of minus 3 square, that is 9, and minus 4 times minus 5, that's it, that is positive 20. So positive 20 times 6. So here we would get square root of 129 divided by 12. The second equation, that would be cos theta equals 3 minus square root of 129 over 12. Okay, now we can find the principal solutions to each one of these expressions. All right, so now if you try to work this one out, okay, so you would end up with math error. Now do not write math error over here, you have to write no solution. And why is that? Let's see what is the value of 3 plus root 129 upon 12. Now this value turns out to be 1.196, right? But we know that the maximum and minimum value of cos theta lies between positive 1 and negative 1. So this value is going beyond 1, right? Which is not possible. Therefore, you are getting no solution. For there is no value of theta for which you can get a value of cos theta, which is 1.196. Okay. All right. So we'll come to this one then. So cos inverse of 3 minus root 129 divided by 12. So, okay, we are required to give our answer in degrees. So remember to change your calculator in degree into degrees mode. All right, so our answer will be 134.1 degree, 134.15 degrees. Let's just make it that. Okay, now we know that this is our cos theta, right? Okay, our cos theta was negative. Okay, how do I know that? If you just try to work out the value of this fraction, that will be minus 0.696. So that means our cos theta is negative. So cos theta is negative in the second quadrant and in the third quadrant. Okay, so therefore my solutions will be over here. Now, one of the solutions that I got is 134.15, which is correct because this is an obtuse angle. The second solution would be over here. Okay, now in order to find this solution, I need to first find out what is alpha, what is the acute angle. Okay, so first of all, I'm going to write that acute angle is 180 minus 134.15. So 180 minus 134.15 gives us 45.85 degrees. Okay, then my theta would be, now I need to find the second solution. So that would be 180 plus 45.85. So 180 plus 45.85, that is 225.85 degrees. All right. Now, so these are the two solutions that we have found. So theta is equal to 134 point. All right. Okay. Now there is something that you must understand here. Whenever you are getting a value of 5, okay, so make sure that you round it to a greater degree. Okay, and there's a reason for that. Let me just quickly work this out. I just missed this earlier. Okay, so here basically what I'm getting is 134.14 146. Okay, now basically that was 5 earlier. Now this could impact your answer and you'll see in a bit. Right now, the answer that I would have got to two decimal places, if I would have used this value, that would be 134.2, which is actually incorrect because you have rounded the value twice. Because now, if you see, if I round this off to one decimal place, I would end up with zero point 0.1. Okay, so this is how you could lose a mark for the final answer. Okay, so that might be that'll be a rounding error then. Okay, similarly, if I am using a better value over here, so these values will also change a bit. So this becomes 134.146. All right, 180 minus 134.146, that will be 45.854, not 48. So this is also 45.854. And when you add this to 180, you would get 225.854 degrees. So now our answer is going to be 225.9 degrees. Okay, so that's your final answer. Okay, question number 3. Now, question number 3 is the polynomial ax cubed plus x squared plus bx plus 3 is denoted by p of x. Okay, so we can say that p of x is equal to ax cubed plus x squared plus bx plus 3. It is given that p of x is divisible by 2x minus 1 and that when p of x is divided by x plus 2, the remainder is 5. Okay, when it says that it is divisible by 2x minus 1, that means that 2x minus 1 is a linear factor. So the remainder would be 0 when you plug in the factor, when you plug in the value of x, you would get the remainder as 0. So from this statement, we know that 2x minus 1 is a linear factor. So f of, or rather p of 1 upon 2 will be equal to 0. Because look, this is 2x minus 1, right? So if I say that 2x minus 1 is equal to 0, the value of x will be 1 upon 2. Okay, all right. And how do we know this? This is we studied this back when we studied about factor theorem. Okay, so this is factor theorem being applied. And secondly, it says that when p of x is divided by x plus 2, the remainder is 5. Okay, so that would mean that if I say that the value of x is minus 2, so p of minus 2 will be equal to 5. Okay, so here we'll get two equations and we will then solve them simultaneously because we have to find the unknown values a and b. So let us first form the equation from this first given information. So we can say that f of 1 upon 2 is equal to a times x cubed. So that will be a times 1 upon 2 whole cubed plus 1 upon 2 whole square plus b times 1 upon 2 plus 3 equals to 0. So this will be 1 over 8a plus 1 over 4 plus 1 over 2b plus 3 equals to 0. If I need to get rid of the fractions, I can multiply both sides by 8. So when I multiply both sides by 8, I would be left with a plus 2 plus 4b plus 24 equals to 0. A plus 4b, so 2 plus 24 is 26. If I shift it to the other side, that would be minus 26. So let's call this our first equation. Or rather, what we can also do is we can actually make a the subject of the formula. So I can rearrange it further. I can say a is equal to minus 4b minus 26. Because now, whatever the second equation turns out to be, I can directly substitute a into that. All right. Now, from the second information, we can say that x plus 2 gives a remainder equal to 5. So p of minus 2 is equal to 5. So first, let us substitute the value. So we have a times minus 2 whole cubed plus minus 2 whole square plus b times minus 2 plus 3 equals to 5. This will be minus 8a plus 4 minus 2b plus 3 equals to 5. So we have minus 8a minus 2b. 4 plus 3 is 7. When 7 goes to the other side, that becomes minus 2. So we can rearrange this and we can say 8a minus 2b equals to 2. Okay, you can further make it a bit simpler. Divide both sides by 2. So this becomes 4a minus b equals to 1. That is my second equation. Now I can directly substitute a into equation 2. So substitute 1 into, so you have 4 times minus 4b minus 26 minus b equals to 1. 4 times minus 4, that will be minus 16b. 4 times minus 26, let me work that out. 26 times 4, so that is minus 104 minus b equals to 1. Minus 16b minus b, that is minus 17b, and minus 104 goes to the other side, becomes 105. So b is equal to 105 divided by minus 17. Just a minute. Oh, sorry, my bad. Okay, so 4 times a, which is minus 4b minus 26. So this is minus 16b, and 26 times 4 was 104. So minus 104 minus b equals to 1. So here we have minus 17b 104 goes to the other side, adds up with 1. So that should be correct. Where's the mistake? Okay, let us see over here. So we ended up with 8A. Oh, okay, I see that. So you see, here I forgot to write this as plus, because when we shifted all of this, right, we shifted minus 8A and minus 2B to the other side, and minus 2 came to this side. All right. So all right, my bad. Let me just fix this up. So this should become minus 15B. So 105 divided by minus 15. So B is equal to minus 7. All right. Now that we know what B is, we can plug in this value back into equation 1. So that will be minus 4 times minus 7 minus 26. Minus 4 times minus 7, that will be 28. Minus 26 equals to 2. So therefore, A is equal to 2 and B is equal to minus 7. All right, question number 4. The equation of a curve is y equals cos cubed x root sine x. It is given that the curve has one stationary point in the interval x between 0 and pi upon 2. So you can see that here we have now in radians. So we should convert our calculator back to radian mode. Find the x coordinate of this stationary point and giving your answer correct to three significant figures. So you can see that they've used the the singular form. So that means there will be only one x coordinate, okay, of the stationary point. So there is only one stationary point in this interval. Okay. All right. So first, let me write this down. So cos cubed x can be written in this form, and root sine x can be written in this form. So we can see that we need to find, in order to find the stationary point, we need to find dy dx. That means we have to differentiate it. So when you have a product of two functions, then we use the product rule. So when two functions are multiplied with each other, then we use the product rule. Okay, so u is equal to cos x whole cubed, and v is equal to sine x to the power half. U dash will be, so 3 will be multiplied. This becomes 2. Multiply by the derivative of what's inside the function. So this is the chain rule, right? You have a function inside another function. So this becomes minus 3 cos squared x sine x. Okay. And on this side, v dash will be 1 upon 2 sine x to the power minus half, multiply by the derivative of what's inside the function. So that will be cos x. So we will be left with cos x upon 2 root sine x. So we can write it in this form. Okay. Now dy dx is equal to, so we know that dy dx is v u dash plus u v dash. So v u dash will be minus 3 cos squared x sine x multiplied by sine x to the power 1 upon 2 plus cos x over 2 root sine x multiplied by cos cubed x. Okay. Now from here, what we can do is we can factorize cos squared x, because you can see that that is the only thing which is common. And why do we have to factorize? Because if I say that dy dx is equal to 0, I cannot solve this equation, right? The only way that you could proceed towards solving is if you write it in factorized form. Okay, and you'll see why in a bit. So first let us write this as cos squared x. Okay, so I've taken this common. What I'm left with is minus 3. Now here we have sine x multiplied by sine x to the power half. So the powers will add up and you would get sine x and the power would be 3 upon 2 plus cos squared x is taken from here. So we'll be left with 1 cos x that multiplies with this. So you get cos squared x over 2 root sine x. Now we can say that as stationary point, dy dx is equal to 0. So we can say that 0 equals cos squared x times minus 3 sine x to the power 3 upon 2 plus cos squared x over 2 root sine x. Now from this, once we have this in factorized form, we can generate two equations. We can say that cos squared x is equal to 0, or we can say that this entire expression is equal to 0. All right. Now, if I talk about the left hand side first, this is cos x is equal to 0. If we take square root of 0 is 0. Now, if I draw a graph of cos x or cos theta, so the graph of cos theta is something like this, right? So this is 2 pi, this is 0, and this is your pi. So we need to find that where cos x is equal to 0. So cos x is equal to 0 over here and over here. This point is pi upon 2 and this point is 3 pi upon 2, but we're not interested in this because our range is between 0 and pi upon 2. But you can see clearly that pi upon 2 is not inclusive. It is not included in the inequality. So therefore, we know that x is equal to pi upon 2, but this is out of range. All right, so that's why we have to reject this value. Now coming to the right hand side, if I shift this expression to the other side, so I'm going to get cos squared x over 2. Now root sine x is sine x to the power half equals 3 sine x to the power 3 upon 2. Now when this sine x to the power half multiplies on the other side, the powers 3 upon 2, which is 1.5, adds with the power 0.5. So therefore, this becomes 3 sine squared x. Okay. Now, what I can do is I can take cos squared x and divide it both sides on the other hand, and I can shift 3 to this side. So basically, what I'm going to be left with is sine squared x over cos squared x, right? Which basically becomes 10 squared x equals to this 2 goes to the other, sorry, this 3 goes to the other side. So that is 1 upon 6. So now I can say that 10x is equal to plus minus square root of 1 upon 6. And from here, we now have two equations. Now, we can use these two equations. We can say that 10x is equal to square root of 1 upon 6. So x is equal to 10 inverse of square root 1 upon 6. That will be equal to something. We'll just come back to it in a bit. 10x is equal to minus root 1 upon 6. X is equal to 10 inverse of minus square root of 1 upon 6. So let's calculate this. 10 inverse of positive square root of 1 upon 6. That will give me 0.388. Okay, and for this one it will give me minus 0.388. Okay, now we cannot take because if you look over here, our range is quite narrow. It is like 0 and 90 degrees. 0 and 90 degrees is just the first quadrant, right? 90 degrees or pi upon 2 radians, it is just the first quadrant, so you cannot go beyond that, right? So now we have to see that our range shows that x is positive, right? Because it is greater than 0 and less than pi upon 2. So therefore we can say, since x is greater than 0, x is equal to 0.388 radians. Now make sure that you give this as final answer. Your statement should clearly show that you have rejected this answer, you have rejected this solution. Is that clear? Because if you just leave your answer in this form, okay, you're going to lose 1 mark because you're suggesting that both of these are solutions, whereas this one does not lie within the given interval. All right, question number 5. By sketching a suitable pair of graphs, show that the equation ln x equals 3x minus x square has one real root. Now here you have to sketch the graph of ln x as well as the graph of 3x minus x squared. So what I can say is, I can say that y equals to ln x, and I can say that y is equal to minus x squared plus 3x. Now minus x squared plus 3x, because the coefficient of x squared is negative, so the shape of our sketch will be in this manner, a sad face. So this is a quadratic equation, quadratic curve, and because of its coefficient being negative, this is the shape that we will get. So let us sketch the graph. Let me draw the axis. All right. Now, if I were to find out that, okay, where the axis of the graph will cut, right? So if I take x common, I would be left with minus x plus 3. Okay. So at y is equal to 0, when y becomes 0, x is equal to 0 and x is equal to 3. So therefore I know that the graph is going to cut the x-axis at 0 and at 3. All right, so that's the first thing. We are not interested, or they are not interested in asking us to what our peak should be or where it should be, what should be the turning point. So we don't really care. So we just needed 2 points, just two coordinates or just two x-intercepts, so that we can mark them on the graph, right? So our quadratic curve should be something like this. Okay, so this is just a rough sketch. So this is how it should look like. So that will be your curve y equals minus x squared plus 3x. Now y equals to ln x, that is a standard graph. Okay, so you have to know how it looks like. Okay, y equals to ln x, okay, goes something like this. It cuts the graph as at 1, and y equals to ln x is actually a reflection of y equals to e to the power x in the line y equals to x. So for example, if I were to draw this sketch, the graph of y equals e to the power x is something like this, right? Now if you reflect, so if let's say you don't remember that what is the graph of ln x, all you have to do is, because this is pretty easy to remember, the graph cuts at 1 over here. So we draw a mirror line at y equals to x, and then we reflect the graph in this line. So if I reflect it, so my graph goes something like this. So you can see that the graph does not approach x-axis because x-axis is the asymptote. Similarly, for y equals to ln x, y-axis is the asymptote, and the graph cuts at 1 over here, so the graph cuts at 1 over here. So if even though if you do not remember or you don't recall how the graph looks like, so this is how you can work it out. Okay, so do not forget to label your graph. So this is y equals to ln x, and this is y equals, let me write it here, minus x squared plus 3x. Okay, now is that enough to just show the graphs? No, you also have to mark the intersection. Okay, just make a small circle over here and just give a conclusive statement. So we can say that since there's only one point of intersection, there's only one root. Okay, so since there's only one point of intersection, there will be only one root to this equation. All right, part B, verify by calculation that the root lies between 2 and 2.8. Okay, so from the graph we can see that the root lies between 1 and 3, so it has further narrowed it down, and he's asking us to verify that the root is lying between 2 and 2.8. Okay, now when you need to verify this by calculation, the very first thing that you have to do is bring all the terms of the equations on one side and make the other equation equal to 0. So we have ln x equals 3x minus x squared. I'm going to move 3x minus x squared to left hand side so that this becomes ln x plus x squared minus 3x equals to 0. Okay, now that you have done this, we're going to say let f of x equals ln x plus x squared minus 3x. Now, if I plug in the value of 2 into this polynomial, so what I'm going to get is ln 2 plus 2 square minus 3 times 2. Okay, you calculate that. Then secondly, we'll work out f of 2.8. So that will be ln 2.8 plus 2.8 whole square minus 3 times 2.8. Okay, so let me grab my calculator. So we have ln 2 plus 2 square, that is 4, minus 6. So this gives me minus 1.31. Similarly, ln 2.8 plus 2.8 whole square minus 3 times 2.8. So that will be 0.470. So now what conclusion can we draw from this calculation? We can say that since there is a change of sign, the root lies between 2 and 2.8. Okay, so basically, let me just give you a quick recap of what this concept is, right? So here, you know that this is your equation, and we can say that y is equal to 0. Okay, we are basically what we are trying to find is that if y is equal to 0, what will be the value of x? Now, where exactly does y become 0? It becomes 0 at x-axis. So if let's say that the curve of this equation, whatever it's going to look like, I don't know, but let's just say that it is something like this. Okay, just for the sake of it, maybe okay, what are the values? We have 2 and 2.8. All right, so let's say that at this is 2 and this is 2.8. Okay, now the value of y when x is equal to 2 is a negative value, so that means it is over here somewhere. Okay, and when the value of y was 2.8, it became positive. So let's say it is over here somewhere. So that means the graph has cut somewhere between 2 and 2.8. It has cut the x-axis somewhere between 2 and 2.8. So whatever this value of whatever the value of x is going to be, okay, that is what our root to this equation will be. So this is how you can see, or how we basically say that there is a sign change. So this sign change actually tells us that the root cuts the curve cuts the x-axis somewhere between 2 and 2.8. Okay, all right. Now part C is use the iterative formula x n plus 1 equals root 3xn minus ln xn. Okay, all right. So here what we're going to do is, first of all, we need to decide that what our value is going to be. Okay, so because they haven't mentioned it, remember the best value that you can select, the initial value, is the middle value between these two. Okay, the midpoint of these two. So you can say that x1 is equal to 2.4. All right, let x1 equals 2.4. All right, now x2 will be root of 3 times 2.4 minus ln of 2.4. Okay, so let's work this out. So we have square root 3 times 2.4 minus ln 2.4. So that gives us 2.5149. For x3, now the value that I'm going to plug in will be 3 times 2.5149 minus ln 2.5149. Now here I'm just going to press the answer button. Okay. In the bracket, I'm just gonna write over here. When I bring my cursor on this point, I'm gonna write answer button over here. Okay, and they'll just plug in the value automatically every time. So I don't have to now manually substitute. So I get 5734. Okay, now when you press the answer button again, so the value of x4, now definitely you have to show the substitution. Okay, so you have to write all of this again and again. That is part of your working. So 3 times 2.5734 minus ln 2.5734. So that will be 2.6029. Okay, x5, the value of x5 will now be 3 times 2.6029 minus ln 2.6029. The value at this point will be 2.6176. Okay, so you can see that, and until this point we can still see the value is not converging, right? I mean, it is converging, but still we do not have a specific value to two decimal places. Here we have 2.60, here we have 2.62. So we will continue until we get the two values which are same, correct to two decimal places. 2.6179 ln 2.6176, sorry, not 79. Let me just grab some water. All right. So let's continue. So 2.6176. Okay, so when we plug in this value now, that will give us 2.6250. So now you can see that here it becomes 2.62, but here it becomes 2.63. So we'll move to one more iteration. 3 times 2.6250 minus ln 2.6250. So now we get 2.6287. So now we can see that finally it converges to 2.63. So that is our root to this equation. All right, question number 6. The variables x and y satisfy the differential equation dy dx equals x times e to the power y minus x and y equals to 0 when x is equal to 0. So this is your initial condition. Solve the differential equation, obtaining an expression for y in terms of x. All right. So first of all, we need to split this term, okay, because it has e to the power y as well as e to the power x inside, right? Now, why do I need to split them up? Because I need to collect the variables of x on one side and I need to collect the variables on y on the other side. So in order to do that, first I have to split this expression. So dy dx equals x times. Now e to the power y minus x. So that basically means e to the power y dot e to the power minus x. That's why the powers are added, right? So e to the power minus x is e to the power y upon e to the power of x. So that's what we can write over here. Now, so we need to separate the variables. So e to the power y will move to the other side and we can move dx to this side and then we integrate them. Okay. Now, integrating e to the power of minus y. So this basically becomes integral of e to the power minus y with respect to y, and this becomes x times e to the power minus x dx. So this one is pretty simple, right? But this one, you can see that this is a product of two functions being integrated. So here we use integration by parts. So let's select u. Now, in order to select u, you should remember this. Now, u is basically that function which is easier to differentiate. Okay, so we go. The way that we decide is by using this word liet, right? Here, L stands for logarithm. Okay, in our case, it will be natural log because your syllabus does not contain questions of integrating or differentiating the logarithmic functions other than the ln functions. Then I stands for inverse of tan, A is for algebra, T is for trigonometric function, and E is for exponential function. So here we have an algebraic fraction and an exponential function. So therefore, because A is first, U is equal to X, and V dash will be equal to e to the power minus X. U dash becomes 1 and V becomes, so integrate e to the power minus X. So that becomes e to the power minus X divided by minus 1, which is minus e to the power minus X. All right. Now, so if I start integrating here, this becomes minus e to the power minus y equals. Now, the formula for integration by parts is, so this is what our question is. So that will be uv minus the integral of vu dash. Then we can write this down. So u is x and v is minus e to the power x. So we can say minus x times e to the power minus x minus the integral of v, which is minus e to the power minus x times 1 dx. Okay, then we can write this down as, now minus minus becomes plus, and now if I integrate e to the power minus x, that becomes e to the power minus x divided by minus 1 plus c. So now you can see that we have ended up with one more negative, right? And also what we can do is we can directly substitute now that y equals to 0 and x is equal to 0. So we can say that at x is equal to 0 and y equals to 0, this is minus e to the power 0 equals 0 because x becomes 0. So this whole expression becomes 0 minus e to the power 0 plus c. So this becomes minus 1 equals minus 1 plus c. So therefore c is equal to 0. So now your constant of integration becomes 0. Plug in this back into this equation. So we end up with minus e to the power minus y equals minus x times e to the power minus x minus e to the power minus x. Okay. So you can see we have negative in every term, right? So if I factorize this expression and take minus 1 common, I can cancel minus from both sides. So my expression becomes e to the power minus y equals x times e to the power minus x plus e to the power minus x. Okay, now we need to make y the subject of the formula because it says obtain an expression for y in terms of x. So now we can take ln both sides. So this becomes ln e to the power minus y equals ln x e to the power minus x plus e to the power minus x. Okay, now here on the right hand side, what we can do is we can factorize them. We can factorize e to the power minus x, right? So we can say that ln e to the power minus x times x plus 1, and over here minus y times ln e. We know that ln e is equal to 1. So this becomes 1, and this minus can be shifted to the other side. So we can say like divide both sides by 1 or multiply both sides by minus 1, sorry. So this becomes minus ln e to the power minus x times x plus 1, and that's your answer. Okay, part B is find the value of y when x is equal to 1, giving your answer in the form a minus ln b. So we just found out that y is equal to minus ln e to the power minus x plus 1. So minus ln e to the power minus x plus 1. It says substitute x is equal to 1. So minus ln e to the power minus 1 times 1 plus 1. That will be ln 2 times e to the power minus 1. All right. So that can also be written as, if I, because here we have to write in this form, right? So that means we have to split the logarithmic function. So first of all, let me write this in this form: 2 over e. Okay, now if I split this, so this becomes ln 2 minus ln e. Sorry, my bad, forgot the negative sign. So this is what it is, right? So this is minus ln 2 minus ln e. Ln e is equal to 1, and when you multiply by this minus, so this becomes minus ln 2, this becomes positive 1. So we can write it as 1 minus ln 2, and that is exactly in the form a minus ln b. All right, question number 7. The equation of a curve is x cubed plus 3x squared y minus y cubed equals to 3. Show that dy dx is equal to x squared plus 2xy over y squared minus x squared. If your derivative contains two variables, okay, so here you have x, you also have y, and if your function, okay, is also comprised of two different variables, x, y. So here we use implicit differentiation. Okay, so this is a question of implicit differentiation. So first of all, what we're going to do is we have x cubed plus, now over here, I'm going to write this in a different color. So this is 3x squared y minus y cubed equals to 3. Now for this particular part, okay, we have to use the product rule. So let's say that u is equal to 3x squared and v is equal to y. So u dash will be equal to 6x and v dash will be equal to 1 dy dx. Because we are differentiating with respect to x, so we have to put dy dx at the end. And this comes from the chain rule. All right. Okay. Now we can just simply multiply them in the form v u dash plus u v dash. Okay. Now for those of you who might be familiar with a much shorter method, okay, so let me also explain that one as well. So here we don't necessarily always have to do the product rule like this. If it's a simple function, what you can do is, let's say that this is my first function. I'm going to write it as it is 3x squared, and I'm going to multiply it with the derivative of the second function. So that will be 1 times dy dx plus, in the second case, I'm going to write the second function as it is multiplied by the derivative of what's the first function. So 3x squared, the derivative will be 6x. Then minus y cubed becomes minus 3y dy dx. Sorry, minus 3y squared dy dx equals to 0. Okay. All right. So now we can expand it and then we'll simplify it. So we have x cubed plus 3x squared dy dx plus 6xy minus 3y squared dy dx equals to 0. So now we can collect all the dy dx terms on one side, and the remaining term will move to the other side. Okay. All right. So what we can do here is, let's say that we have 3x squared. So we can factorize dy dx, right? So we can say dy dx times 3x squared minus 3y squared, and the rest of the terms I've moved them to the other side. So this becomes minus x cubed minus 6xy. Okay. All right. Now I can say that dy dx is equal to minus x cubed minus 6xy divided by 3x squared minus 3y squared. All right. I think I did a mistake. I did not differentiate this, right? Right. Let me just fix that up. Okay. So x cubed will be differentiated to 3x squared. So this becomes 3x squared, and this becomes 3x squared, and this becomes 3x squared. All right. Now here what we can do is we can take minus 3 common. So I can say minus 3, and we have x squared plus 2xy. Now you look, you have to bring your answer into this form, right? So you have to constantly see that, okay, am I getting closer to the required form? So after I have taken minus 3 common, then yes, now I am getting closer to this form. Then we have 3 common at in the denominator, so we can say x squared minus y squared. This 3 cancels with this 3, so you're left with minus. Now look, the top part is perfectly fine, but the bottom one, that's a bit different, right? Because here it is y square minus x square, whereas what we are getting is x square minus y square. So what we can do is we can take this negative sign in the denominator. So I can say minus x square, sorry, minus y square, and then I can multiply it out. So that will give me dy dx equals x squared plus 2xy. Now over here, this becomes minus x squared and this becomes plus y squared. So I can rearrange it and I can write y squared minus x squared. And this is the required form that we have achieved, right? Okay. All right. So let's move to the next part. Now it says find the coordinates of the points on the curve where the tangent is parallel to the x-axis. Okay, the tangent is parallel to the x-axis. If it is parallel to x-axis, that means, oh sorry, my bad, parallel to x-axis is this. Now when you have a straight line in this form, you can see that for every point on this curve, your y value is going to be the same, right? So let's say maybe this is y equals to 4. Now at every single point y is equal to 4. So if I were to ask you that what is the change in y, because the gradient is change in y over change in x. So change in y is going to be equal to 0. So no matter whatever we have, whatever change in x is, even if it's 1,000, okay, your gradient is going to be equal to 0. So what part of our gradient is actually 0? It is the numerator. Okay, so first of all, let me write down dy dx. So that was x squared plus 2xy divided by y square minus x square. Okay, so we can say that since delta y is equal to 0, okay, so we can say that x square plus 2xy is equal to 0. We don't have to write the whole thing equal to 0 because it is this specific portion of the denominator of the gradient function that is equal to 0, which is the numerator. So we can just write this down. Okay. All right. So what I can do here is I can factorize x. So I'll be left with x plus 2y equals to 0. So I get two solutions. X is equal to 0 and the second is x equals minus 2y. Okay. Now what I'm going to do is, now I have found the first x coordinate, okay, of the point where the tangent is parallel to x-axis. The second point I'm going to find out if I substitute x equals minus 2y into the original equation. So substitute x equals minus 2y in the original equation of the curve. Okay. All right. So the original equation is x cubed plus 3x squared times y, x cubed plus 3x squared times y, which is minus, oh, so we have to, sorry, we have to substitute. Okay, that would require a lot of substitutions, wouldn't it? If I just substitute what y is instead, if I, let's say, y equals to minus half x, if I do that, then that would require me to do less substitutions, right? So I can do that, minus half x. Okay, then we had minus y cubed, so that was minus y cubed equals to, just realize it's actually the same. You have to substitute twice. So let me just stick to this one then, because if I use this, then it's going to end up in fractions. I don't want fractions. So let's just make our life easier. Okay, so we have x cubed, right? So this means minus 2y whole cubed plus 3x square means minus 2y square times y minus y cubed equals to 3. All right. Okay, now, so let's see. So here we are trying to find the value of y, right? So what we are trying to find here is that at x is equal to minus 2y, what will be the value of y, right? So let's try to work that out. So this becomes minus 8y cubed, then this becomes 4. Okay, so minus 2y whole square, that is 4y square times 3y, so that will be 12y cubed minus y cubed equals to 3. So this will be 3y cubed equals to 3. So that means y cubed is equal to 1, and that means that y is equal to 1. Okay, so that'll be our first coordinate. So that means that when x is minus 2y, y is going to be 1. All right. Okay, now this x coordinate is in terms of y, right? So we can further work this out, that that at x is equal to minus 2y, sorry, at y equals to 1, what is the value of x? So at y equals to 1, x is equal to minus 2y, which was 1, right? So minus 2. So therefore now this coordinate will be minus 2 comma 1. That's our first coordinate. The second coordinate that we need to find will be that what happens when x is equal to 0, and I'm going to substitute in the same equation. So our equation is 3x cubed, sorry, x cubed plus 3x square plus 3x square y minus y cubed equals to 3. So at x is equal to 0, this becomes 0, this becomes 0, minus y cubed equals to 3, y cubed equals to minus 3, and if I take cube root, so that would mean y is equal to cube root of minus 3. Okay, so therefore coordinates are, the first one that we found was minus 2 comma 1, and the second one was 0, cube root of minus 3. Okay, question number 8. Let f of x equals x squared plus 9x divided by 3x minus 1 times x squared plus 3. So we know that this is x squared plus 9x divided by 3x minus 1 times x squared plus 3. So this is a linear factor and this is a quadratic factor, right? So it says express f of x in partial fractions. So this will be a upon 3x minus 1. And because our second factor is a quadratic factor, the denominator should be a linear factor or a linear expression. So this will be x squared plus 3. Multiply both sides by this entire denominator. So you would get a times x squared plus 3 plus bx plus c times 3x minus 1. Now, So what we're going to do is we'll try to eliminate different constants so that we have to choose the values of x in a way that we are able to eliminate two of the constants. So we need to find a, we need to find b and c. So let us first choose x equals 1 upon 3. So let x equals 1 upon 3. Why 1 upon 3? So that I'm able to cancel this entire expression. If I substitute 1 upon 3 over here, this becomes 0, and because of this 0, this entire bracket also becomes 0. So I will be left with only a. So this is 1 upon 3 whole square plus 9 times 1 upon 3 equals a times 1 upon 3 whole square plus 3 plus, because we know that when we substitute this will become 0, so we can just write it as 0. Now 1 over 3 whole square is 1 over 9, and 9 times 1 upon 3, that is 3, equals to, so this becomes a times 1 upon 9 plus 3. So you can see that they are the same expressions, right? So if I divide this whole thing on the other side, or if you want, you can work it out as well. So this basically turns out to be 3 plus 1 over 9, that will be 28 upon 9. So 28 over 9 equals to 28 over 9a. Therefore, a is equal to 1. All right. Now, if I can cancel b, then I can find out c. So if I say that let x is equal to 0, so b is going to cancel out. And even if a doesn't cancel out, no problem. I have already found the value of a. So let x is equal to 0. So on the left hand side, we'll have 0 because both of them are both of them, they have x, right? Then here we have a times 0 plus 3 plus, now just because this x becomes 0 does not mean that everything is going to become 0. Only b is going to become 0. So we have 0 plus c times 0 minus 1. Okay, so don't be too hasty into thinking that okay, if I do this 0, everything is going to become 0. All right. All right, so this is 0 equals 3a, and now we have already found the value of a, right? So we can now substitute. So is 1 plus, this becomes uh, minus c, right? So now if I move c to the other side, so c becomes positive, so therefore c is equal to 3. Now by substitution we can only find two unknowns, so we can now use a different method, which is comparing the coefficients. So we can say comparing the coefficient of x square. It is better to use the highest available power, okay, if your unknown constant is part of it, because because in that case you have few terms to deal with. So if let's say that if I were to compare the constants are actually more, right? So it is a better idea to use the highest available power. So in this case, the coefficient of x squared is 1 on left hand side, and on the right hand side a multiplies by x squared, so we have a, and over here we have bx multiplied by 3x, so that will be 3bx squared. So therefore this will be 3b. We know that the value of a is 1, so when this 1 goes to the other side it becomes 0. So therefore b is equal to 0. So now f of x will be 1 upon 3x minus 1 plus, now bx, so b is 0, right? So we only have a constant which is c, that is 3. 3 over x squared plus 3. So that is the answer to part A. Then it says, hence find the integral of f of x with respect to x between the limits 3 and 1, giving your answer in a simplified exact form. Okay, so let us first write down what we found. So our f of x was 1 upon 3x minus 1 plus 3 upon x squared plus 3. Okay. All right, let's see. This one, we can recognize that this is in the form f dash x over f of x, except that we have to do some minor adjustments, right? Like, for example, the derivative of this function is 3. So we can introduce 3 over here. We can say that this is 3, and then outside we can write 1 upon 3. Okay, this is the original expression. Okay, on this side we have 3 over x squared plus 3. Now you can see that this is not in the form f dash x over f of x. Okay, that's the first thing. Secondly, we can also not apply the chain rule. So we can't do that x square plus 3 to the power minus 1. Why? Because when you try to integrate this, you have to add 1 to the power, okay, so which is plus 1. So this becomes 0, and then you have to divide by the new power, so that becomes undefined. So now remember one thing. The first one is the chain rule, which is this one. If this doesn't work, look for lin, okay, just like this one. So here the chain rule does not work, but we can see that your function is in the form f dash x over f of x. So that we have applied here. But if both of these do not work, then you look for tan inverse. Okay, so now the standard result related to tan inverse is that if I have an expression in the form 1 plus x squared dx, that will be equal to tan inverse of x plus c. That's the standard result. Now, how much different is our result over here? Another result that we know is that 1 over a squared plus x squared. If you have in this form, okay, we can write it in this form actually. Okay, how can we write it in this form? This is x squared. Now, what is the number if let's say if I have a number and I square it, so I should get 3. What is that number? That number would be root 3, right? Because if I take square root of 3 and I square it, so I'm going to get this. So this is actually in this form. So therefore, the standard result tells us that it will be 1 upon a tan inverse x upon a, okay, plus c. Now definitely this is a definite integral, so we don't have to write c, but this is the standard result that we have to use. Okay, all right, so let us put the integration side. So here we have 3 and this is 1. Now we can integrate this. So this becomes 1 over 3 ln 3x minus 1, and over here we have 3 times 1 over root 3. This 3 is just a constant, right? So we can just take it outside. And then we have 1 upon a, just you can just follow this standard result. So 1 over root 3 tan inverse of x upon root 3. I don't know why it just I'm keep thinking that this is 13 for some reason. Okay, so 3 and 1. So these are the limits that we have plugged in. Okay, all right, now let's see. So we can't really factorize much from here, so we can start plugging in the values. So we have 1 over 3 ln 3 times 3 minus 1 plus 3 over root 3 tan inverse 3 upon root 3. Okay, so that's the first one. The second would be 1 over 3 ln 3 times 1 minus 1 plus 3 over root 3 tan inverse of 1 upon root 3. Okay, now if I simplify it, now don't just put the whole thing in calculator. Okay, do not do that. You can't even do that actually, because if you would do that, your answer would be in decimals, whereas you're needed to give your answer in exact form. So find out one by one. So we have 1 upon 3 ln 3 times 3 is 9, 9 minus 1 is 8. So we have 1 over 3 ln 8 plus over here we have 3 over root 3, and if I work this out, so let's see, that would be tan inverse of 3 upon root 3, which is pi upon 3, minus 1 over 3. So we have ln 2 minus 1, so that is ln 1. Okay, ln 1 is basically 0. Oh, sorry, my bad. This is 3 times 1, right? 3 times 1 minus 1, that is ln 2. All right, so this is ln 2 plus 3 over root 3, and let me work this out. Tan inverse of 1 over root 3 gives us pi upon 6. All right, so let's open up the bracket. So we have 1 over 3 ln 8 plus 3 and 3 cancels out, so you have pi over root 3, or you can write it in this form if you want. We can say 1 over root 3 times pi minus 1 over 3 ln 2 minus 3 and 3 will cancel. So basically here we have 2, right? So we can write this as 1 upon 2 root 3 pi. Now we can collect the like terms. So we have 1 over 3 ln 8 and we have 1 over 3 ln 2. So let's write them together. And on this side we have 1 over root 3 pi minus 1 over 2 root 3 pi. So now when you simplify this, you can see that the coefficient of ln is actually the same. Only then you can apply the rule of logarithm. Okay, so when you have the same coefficients on both sides, so we have 1 over 3, we have 1 over 3. So what I can do is I can now write that 1 over 3 ln 8 upon 2 is just like saying that, okay, I have first factorized 1 upon 3 outside and I'll be left with ln 8 minus ln 2. So now I can apply that. But if you have different coefficients going on, you cannot do that. Okay, keep in mind. Then this becomes 1 over root 3 minus 1 over 2 root 3. That will give us pi upon 2 root 3. Okay, because this is just like saying that this is 1 and this is half of this, right? So you'll be left with another half. So this becomes 1 over 3 ln 4 plus pi over 2 root 3. Okay, so yeah, I think that's it because we can't simplify any further. Okay, now this is an acceptable answer. Okay, but if let's say that you don't want your certs to be in a denominator, you can rationalize it. So if you want to take it one step more, so what you can do is 1 over 3 ln 4 plus pi over 2 root 3. Now you multiply this by root 3 upon root 3. So this becomes root 3 pi over root 3 times root 3, that becomes 6. So 2 times, sorry, that becomes 3. So 3 times 2, that becomes 6. Okay, so you can also give your answer in this form. So that will be your final answer. So both of them are acceptable forms because the question did not ask you to give in any specific form. It only told you that your answer should be simplified. It should be in exact form. So that's why both of these are simplified and both of these are in exact form. All right, question number 9. the lines L and M have vector equations, okay, respectively. So this is for L and this is for M. All right. Then it says, given that L and M intersect, show that 2b minus a is equal to 4. Okay. So here, if they both are intersecting, that means that there should be a position vector which is the same for both of them, right? Because if let's say that this is line L and let's say that this is line M. Now, this is your point of intersection. Wherever this point of intersection will be, both the vector equations will give you the same answer. Now, first of all, you need to understand what is the output of a vector equation. Like, what does it give you? So this vector equation will give you the position vector of that point which lies on the line. Okay, so that is what your R is actually. So if let's say that for any value of lambda, okay, if let's say that I plug it, let's say lambda is 0. Okay, so when lambda is 0, this term goes out. You'll be left with minus I plus 3j plus 4k. So this will be the position vector of that coordinate for which the lambda is equal to 0. Lambda is just like a scalar multiple. Okay, all right. So we can write this first, that at intersection, position vector from both vector equations is equal. That means we have to equate and find the equations for both of these vector equations, right? So we have to find, so basically let's see what we mean by that. First, let us write this in a simplified form. So this is equation, this is line L, and R is equal to minus 1, 3, 4 plus lambda 2 minus 1 minus 1. Okay, so I've written this in column vector form. So this will be equal to minus 1 plus 2 lambda, 3 minus lambda, and 4 minus lambda. So this will be the position vector, okay, for which we do not know the value of lambda yet. Okay, let's write for M. For M, R will be 5, 4, 3 plus mu A, B, 1. So this will be 5 plus A mu, 4 plus B mu, and 3 plus mu. Okay. Now, because as I mentioned that the position vector will be the same, that means this will be your x coordinate. This will be the I component. So we can now compare the components with each other. So I component and this I component will be the same, or for better understanding, this x coordinate and this x coordinate will be the same. This y coordinate and this y coordinate will be the same. This z coordinate will be the same. Okay, so now we can say that minus 1 plus 2 lambda is equal to 5 plus a mu. That's your first equation. 3 minus lambda is equal to 4 plus b mu. That is your second equation. And 3 plus 4 minus lambda is equal to 3 plus mu. That is your third equation. Now, the question asks you that you need to show that 2b minus a equals to 4. So what we have right now, okay, you can see that there are four variables in overall, right? Overall, we have four variables. We have lambda, we have mu, we have a, and we have b. A and b are not variables, these are actually constant. Even lambda and mu are also constant, but just for the sake of understanding. So these are four different constants. Now the equation that we need to find out it should have only B and A. So that means I have to eliminate lambda as well as mu. So from the given equation, if I subtract, let's say, equation 3 and equation 2. So if I do this, equation 3 minus equation 2. So let us first write that down. So 4 minus lambda equals 3 plus mu. 3 minus lambda equals 4 plus b mu. So this is equation 3, this is equation 2. I'm subtracting them. So what we are left with will be, sorry, what is wrong with this? Okay, 4 minus 3 will be 1. This will be cancelled. Okay, then we have 3 minus 4, that is minus 1, and mu minus b mu. So that will be mu minus b mu. Okay, all right. Now what we can do here is we can make mu the subject of the formula, and then that would give us our expression in terms of b. So what we can do here is we can say that 2 equals mu times 1 minus b. So therefore mu is equal to 2 over 1 minus b. Okay, now from equation 3, if I substitute, so we have 4 minus lambda. So if I substitute the value of mu, the expression of mu into equation 3, so we have 3 plus 2 over 1 minus b. That would give us 4 minus 3 minus 2 over 1 minus b. Okay, so here what we have done is we have made lambda the subject of the formula. Oh, sorry, I didn't write that. Lambda equals 4 minus 3, and therefore we can say that lambda is equal to 1 minus 2 over 1 minus b. So if I multiply 1 minus b over here and at the bottom, so we can now combine them. So this will become 1 minus b minus 2 upon 1 minus b. So you'll be ending up with minus 1 minus b over 1 minus b. All right. So that is lambda. Now you have found lambda and mu both in terms of b. So now we can substitute lambda and mu in equation number 1. Okay, why in 1? Because we have already used equation 3 and 2, so we cannot put them back into this. All right, because we generated these two expressions using these equations, so now we have to use a new equation, something that had nothing to do with these expressions. Okay, all right, so what we can do here is we can say that okay, first of all, what is our expression? We have minus 1 plus 2 lambda. So I'm going to write minus 1 plus 2. Instead of lambda, I'm going to write minus 1 minus b over 1 minus lambda equals 5 plus a mu. So 5 plus a times mu. Mu was 2 over 1 minus b. Okay, if I simplify it, so I would get 1 minus, let me just write this down over here. All right, so here we would get minus 2 minus 2b over 1 minus b. All right, so we just multiply it. Okay, just a minute, because I don't think we have enough space, right? Yeah, okay. All right, let me just write it in this one line so we have enough space to write complete our answer. Okay, so here we're gonna write 5 plus a times 2 over 1 minus b. So that would give us minus 1 minus 2 minus 2b over 1 minus b equals 5 plus 2a over 1 minus b. All right, now this can be simplified and we can write it as minus 2 minus 2b over 1 minus b minus 2a over 1 minus b equals to 6, right? So we collect all the variables on one side and the constants on the other side. Okay, now what we can do here is we can multiply by 1 minus b on both sides. Okay, when we do that, we'll get rid of 1 minus b from this part and from this part. So we'll be left with minus 2 minus 2b minus 2a equals to 6 times 1 minus b. That will be minus 2 minus 2b minus 2a equals to 6 minus 6b. Okay, then if I simplify it further, so I'll be left with 6b minus 2b minus 2a equals to 6 plus 2. 6b minus 2b, that is 4b minus 2a equals to 8. Now if you divide both sides by 2, you will end up with 2b minus a equals to 4, and that is your answer to part A. So this one was a little bit tricky. Okay, it conceptually it wasn't difficult, to be very honest. It only became difficult because you do not know what is A, you do not know what is B. Otherwise, if you had to find directly the coordinates, that would have been much simpler, right? But you had to, so this part required a lot of algebraic manipulation. That's why it became a bit more challenging. All right. Okay, so let's move to part B. Given also that L and M are perpendicular, find the values of A and B. Now we know that L and M are perpendicular. If they are perpendicular, so what we know about this is that their scalar product, or also known as dot product, will be equal to 0. Okay, so that is what you should understand, that when two lines they intersect, okay, and they intersect at 90 degrees. Perpendicular means intersecting at 90. So if let's say this is your line L and this is your line M, right? So they intersect at 90 degrees. That is when we say that their scalar product is going to be equal to 0. So perpendicular means scalar product equals to 0. Okay, now for this we only consider direction vectors. Okay, we only consider the direction vectors. So the direction vector of, let me write this down, direction vector of L times direction vector of M. So that would be, okay, for L we have 2 minus 1 minus 1 and AB 1. 2 minus 1 minus 1 dot AB 1. Okay, and this is equal to 2A minus B minus 1 times 1, that is minus 1, and now we can finally equate this to 0. So here we can see that we have 2a minus b equals to 1. All right, so I can make b the subject of the formula. So what I can do is, so okay, so instead of doing this, we can just take b on the other side. So we'll have 2a minus 1, because we already found one equation in the previous part and we have now a second equation. So I can now substitute this b into the first equation. So from part A, 2b minus a equals to 4. So now I can substitute. So we have 2a, 2 times 2a minus a equals to 4. 4a minus 2 minus a equals to 4. So 4a minus a, that will be 3a, and minus 2 goes to the other side, becomes 6. So therefore a is equal to 2. Then from equation 1, b is equal to 2a minus 1. So 2 times 2 minus 1, that is equal to 3. So therefore a is equal to 2 and b is equal to 3. Now it says in part C, when A and B have these values, find the position vector of the point of intersection of L and M. Okay, now you have to find the position vector, and position vector is given by the vector equation. So what we can do is we can use the vector equation of any one of them. So let's say that I'm using for M, the vector equation was, all right, this one, 5 plus A mu, 4 plus B mu, and 3 plus mu. Okay, so we have 5 plus A mu, 4 plus B mu, and 3 plus mu. Okay, now the value of mu, we haven't found it yet. Okay, but we knew the expression, right? We wrote it somewhere here, 2 upon 1 minus B. So that will be 2 upon 1 minus 2. Sorry, B is 3. 1 minus 3. That will be 2 upon minus 2, which is equal to minus 1. So therefore, we can say that R is equal to 5 plus A is 2 and mu is minus 1. Then 4 plus B is 3, mu is minus 1, and 3 plus mu, that will be 3 minus 1. So that turns out to be 5 minus 2, that is 3, 4 minus 3, that is 1, and 3 minus 2, that is 2. So 3, 1, 2, this is the column vector. But when you have to give your position vector, okay, so always remember that you have to give in I, J, and K notations. So therefore position vector equals 3i plus j plus 2k. All right, last question, question number 10. The complex number minus 1 plus root 7i is denoted by u. So u is equal to minus 1 plus root 7i. It is given that u is a root of the equation 2x cubed plus 3x squared plus 14x plus k. All right. Okay, let me just drink some water before I continue this question. All right. So the complex number minus 1 plus root 7i is denoted by u. It is given that u is a root of the equation 2x cubed plus 3x squared plus 14x plus k equals to 0, where k is a real constant. Find the value of k. So we have to substitute u back into x. Okay, and then we have to find what the value of k is. Okay, so that basically means 2 times minus 1 plus root 7i whole cubed plus 3 times minus 1 plus root 7i whole square plus 14 times minus 1 plus root 7i plus k equals to 0. So now we have to first work out what the expression will be when we take cube of this complex number and when we take square of this complex number. Okay, so let's work that out over here. Let us first work out minus 1 plus 7i minus 1 plus root 7i whole square. So that means minus 1 plus root 7i multiplied by minus 1 plus root 7i. That would be minus 1 times minus 1 is 1. Minus 1 times root 7i is minus 7 minus root 7i. Root 7i times minus 1 again minus root 7i, and root 7 times root 7, that will be plus 7i square. Okay, now we know that the value of I square is equal to minus 1, so this will be 1 minus 2 root 7i plus 7 times minus 1. So therefore this will be minus 7 and 1, right? So that will be minus 6 minus 2 root 7i. All right. Now if I need to work out the cube of minus 1 plus root 7i, the cube of that basically means the square of this, square of u multiplied by u. So we already worked out the square, right, which is this one. So minus 6 minus 2 root 7i whole square. Oh, sorry, not whole square. Minus 1 plus root 7i. Now this will be 6. Okay. So minus 6 times minus 1, that is positive 6. Minus 6 times root 7i is minus 6 root 7i. Then minus 2 root 7 times minus 1, that will be plus 2 root 7i, and then minus 2 root 7 times root 7. Root 7 times root 7, that will be 7 times minus 2, so that will be minus 14i square. Okay, and then again when we plug in the value of I square as minus 1, so I would get minus 14 times minus 1, which is positive 14. 14 plus 6 will be 20. So 20 minus 4 root 7i. Okay, because I don't have enough space, that's why I'm not working it in that manner. So now we can substitute, because now we found the cube, we found the whole square. Okay, so now we can work this out. Therefore 2 times, so from here now we're going to substitute the expressions that we found out. So 2 times 20 minus 4 root 3i, sorry, root 7i, plus 3 times minus 1 root 7i whole square, which is this value, this expression, minus 6 minus 2 root 7i, and then plus 14 times. Okay, so this will be, we can just work it out right now. Okay, let's just write it first. So minus 1 plus root 7i plus k equals to 0. All right. So 2 times 20, that will be 40, minus 8 root 7i. Then we have minus 18 minus 6 root 7i. Then we have minus 14. Then we have plus 14 root 7i plus k equals to 0. Okay, let me just double check. All right, so 40 minus 18 minus 14, that will be 40 minus 32, so we would get 8. Okay, then minus 8 root 7 minus 6 root 7, that makes minus 14 root 7i. All right, and here we have plus 14 root 7i. All right, then we'll be left with plus k, so this cancels out and this cancels out, so therefore the value of k will be minus 8. Okay, all right, so let's see. Part B, find the other two roots of the equation. Now here what we're going to do is, first we need to understand that because our original equation has all the coefficients of x, like x cube is 2, the coefficient of x square is 3, and for x is 14. So all of these are real numbers. So when all the coefficients that contain the x term are real numbers, that means that this is going to give you a complex conjugate. Okay, so if let's say that your first root is u equals minus 1 plus root 7i, so your other root will be the conjugate of u. So we can say that one complex root is minus 1 plus root 7i. So therefore, second root will be its conjugate. So therefore, we can say x is equal to minus 1 minus root 7i. So that is the conjugate. Okay. All right. Now, for the other factor, because this is a cubic equation, we found two roots, right? All right. Now, there are two ways in which you can approach this type of question. We know that a cubic equation has, if let's say that a cubic equation is in this form, ax cubed plus bx square plus cx plus d, right? So its factorized form is something like this, where we have x minus p, x minus q, and x minus r, right? If I factorize this, I would end up with something like this. All right. Now, when this is the case, okay, so let's say that we know two of the roots, right? So we know that x is equal to minus 1 minus root 7i, that this is the second one, and this is the first one. So we can write it in this form, x minus, and instead of p, I can write what the first root is. That's my first bracket. Second bracket will be x minus, okay, and now I'm going to write the second root, which is minus 1 minus root 7i. I don't have to write the third one because I do not know the third one, right? All right. Now what I'm going to do here is, let us first expand. So this becomes x plus 1 minus root 7i, and this becomes x plus 1 minus, plus root 7i. Okay. Now we know from the rules of algebra that if you have, let's say this is A, and let's say that this is B. So this is A, and this is A, and this is B, and this is B. So we know that if we have A plus B times A minus B, so isn't this in the same form? So that actually is A square minus B square, the difference of two squares, right? So therefore, what I can do is I can write this in the form A square minus B square. Okay, so root 7i, that is your B and whole square. When I do this, so x plus 1 whole square, that will be x squared plus 2x plus 1 minus root 7 whole square becomes 7, and I square, that is I square itself is minus 1, so minus minus, that will give you plus. Now it might look a bit confusing. Okay, sorry, I think I forgot. Yeah, there should be 1, right? Okay, x square plus 2x plus 1, and then this becomes minus 7 times minus 1, so this should become plus 8. Basically, why did we have to do this in the first place? Because look, when you have a cubic equation, okay, and you know two of the factors, if you can multiply those two factors and find the quadratic factor, you can use the long division to find the third root, which will be your linear root. Okay, so that's exactly what we're going to do now. So our equation is 2x cubed, let me look at it, 2x cubed plus 3x squared plus 14x plus 3x squared plus 14x minus 8, right? So now if I do long division, So here we are doing long division. The factor that we found is x squared plus 2x plus 8. So 2x cubed divided by x squared. So that gives us 2x, right? So I'm going to multiply everything by 2x. So 2x cubed plus 4x squared plus 16x. You subtract both of them. This becomes 0. 3x squared minus 4x squared, that is minus x squared. 14x minus 16x, that is minus 2x, and minus 8. So you can see it is almost identical, except we just multiply by minus 1. So therefore 2x minus 1 is a linear factor. Okay, therefore the root basically means x, right? So x is equal to half. So I'm just going to write my final answers here. X is equal to minus 1 minus 7 minus root 7 I, and x is equal to 1 upon 2. So this is your final answer, because the question asked you to give the two other roots to this equation. All right, that is the end of part B. Okay, now as I mentioned that there is a second way to do this as well. Okay, now that second way will help you to find the quadratic factor. Okay, now usually the quadratic equation that we have is in the form that let's say that we have x squared minus the sum of the roots. Okay, the sum of the roots plus the product of the roots. So this will be sum of the roots times x plus the product of the roots. Okay, now here we have x square minus, so some of the roots will be the roots that we found were the conjugates one, right? So we had the first root and the second root, so I can say minus 1 plus root 7I minus 1 minus root 7I plus minus 1 plus root 7I multiplied by minus 1 minus root 7I. That is the product of the roots. Now when you simplify this, okay, you can see that plus root 7I and minus root 7I, they cancel out. Okay, you have x square minus, so this is minus minus 1, so that will be minus 2, right? So minus minus becomes plus, plus 2 plus minus 1 times minus 1, that is positive 1, and this will be root 7 whole square, so that will be plus 7, because I square also becomes minus 1. And yeah, sorry, forgot to write x over here, and that basically becomes x square plus 2x plus 8. All right, so basically this is another way that you can achieve to this point. And once you have got your quadratic factor, you can now use the long division method to work out the third linear factor. All right, part C. On an Argand diagram, sketch the locus of points representing complex number z satisfying the equation z minus the modulus of z minus u equals to 2. So here you have to sketch the locus of points. All right, you don't have to shade anything. You just need to draw the what is represented by this equation. So first of all, we know that our equation should be in the form, okay, always. So first we're going to write it over here, z minus u. So minus u basically means u was 1 minus 1 plus root 7I. So we can see that this is already in the required form, right? So we know that the distance of z from minus 1 root 7I is equal to 2. So this is what's represented. Locus is basically all the points, right, that satisfy all the complex number z which satisfy this equation, right? So basically this would mean that we are talking about a circle whose center is minus 1 root 7I and the radius is equal to 2. Now, how do we know that this is a circle? Because whenever you have modulus on one side and you have a constant on the other side, so that is always a circle. Okay, all right. Now we can sketch this over here. So this is the imaginary part of z and this is the real part of z. So let's say that if I label the axis first, so we have 1, 2, 3, and here let's say this is minus 1, minus 2, minus 3. Okay, then over here we have 1, 2, so this will be basically I, this is 2I, this is 3I, 4I, and this is 5I. Now the center is at minus 1 root 7. So this is minus 1, and if we use a calculator and see what is root 7, so root 7 is 2.65. Okay, root 7 is about 2.65, so it should be between 2I and 3I. So should be about here somewhere. Okay, so this is my center, and I can write here that this is root 7. Okay, all right, so let us now draw the circle. Okay, it says 2 units, right? So from here 2 units should be this line over here, and from here it should be, oops, about here. Now from here 2 units would be actually between 4 and 5. And from here there'll be 1 and 2, so just a little bit up. Okay, so something like that. All right, so that's your circle, and that is the answer that we have to give, because we don't have to shade anything. This is the only thing that is required from you. Okay, so that was part C. Now in part D, it says that determine the greatest value of argument of z for points on this locus, giving your answer in radians. Okay, so you need to determine the greatest value of argument of z. So argument of z is also in this form, right? So because it just says z, right? So that means it is understood that what he's trying to say is that we need to find the angle of z from 0, 0. Okay, and what we are trying to find is the greatest angle. This is what our question is. Okay, all right, so let's see. If I start from here, then the greatest angle that you could have, so let's say that this is your point 0, 0. Let me, right, so I'm going to start from here. Now the greatest angle will be the greatest point, right, from here. So we're going to start from here and all the way. If we go, so this is the start of the circle, but we have to go all the way beyond. So you can see the angle is increasing and increasing, and until this point here, this point. So this is the angle that is required. Okay, that's the angle that we need to find, because z is all the points which are lying on this line. Okay, which are lying on the circumference of the circle. All right, now in order to find this angle, we know that the first part of the angle, or let's just say that first of all, if I draw some lines, if I draw a straight line from here, dotted line, okay, so we know that this is 90 degrees, okay, and I'm going to draw a straight line from here, just a little bit more. All right, so we can draw a straight line from here to here, and then we can draw a straight line towards this side. Now look closely. The angle that we need to find has three sections. Okay, the first section is that you start from the x-axis and you go all the way up to the y-axis, this part which is 90 degrees, or in our case pi upon 2 radians. Then we need to find this part over here. So let's say that this is uh, let's say this is beta and this one is alpha. Then it also has a third part, and that third part is what's inside this triangle. So let's say that this is lambda. Okay, so your argument of z is comprised of three angles. Argument of z is equal to alpha plus beta plus lambda, right? Okay. So I hope that this is clear. So we, that means that our theta is actually, we already know that pi upon, this is pi upon 2. We need to find what beta is, and we need to find what lambda is. Okay, and once we know that, that is what our total angle is going to be. All right, so let's work that out quickly. So step one is we're going to write that argument of z is equal to lambda plus beta plus, okay, then from here the first thing that we can work out is that our alpha is going to be pi upon 2 radians, okay, because that was 90 degrees. Okay, step number 3, we're going to work out what beta is. Okay, now the beta is basically the argument of u. Okay, or you can also work it out from this triangle. Okay, let me show you on the graph how we got this triangle. You can see that this is the triangle that we have over here. So the vertical height of this triangle, that is root 7, then the base of this triangle, that is 1. Okay, and then you can see that this forms a triangle. So this is 1 and this is root 7, that is 90 degree, and this is the required angle beta. So here we can say that tan beta is equal to opposite over adjacent, so that will be 1 upon root 7. So therefore beta is equal to tan inverse 1 upon root 7. Okay. All right, step 4, now we need to find what lambda is. Now for lambda, what we can do is, if we look at the graph again, so we can see that this is a triangle. Within this triangle you have lambda, and this is the radius, right? So this will be 2 units, because we know that this is a radius and we know the radius is 2. So we can draw another triangle, that is lambda, that is 90, and that is 2. But in order to find lambda, we need to know what this length is. Okay, this length, okay, now pay attention, this length, if let's say this is x, right, this length is the same as this length. If you look over here, this is common to both the triangles. So this length is common to both the triangles. So therefore, if I can find this x, so I can simply use Pythagoras theorem to work this out. So I can say that x is equal to root 7 whole square plus 1 square, and that would give me root 8. Okay, so this root 8, that is what the value of x is. And now I can see this is opposite upon hypotenuse, so we can say that sine lambda is equal to 2 upon root 8. Therefore lambda is equal to sine inverse 2 upon root 8. And let me work this out. So this turns out to be exactly pi upon 4. So now we have all the components. We can now finally work out the argument of z, which is alpha, that was pi upon 2, plus beta, which is tan inverse 1 over root 7, because this one does not give you an exact value, plus pi upon 4. Now when you add all of them up, so let's see, pi over 2 plus pi over 4 plus tan inverse of 1 divided by root 7. So that gives us 2.72 radians. So this is the greatest value for the argument of z. All right, so that is the end of exam paper. I hope that if you had any questions or any doubts related to this paper, then those were clarified. A good practice will be that after you have seen the whole worked solution to this paper, then it's a good idea then you print this paper and try it out yourself. Even if you don't print it, just try this whole paper by yourself. And first of all, make sure that you strengthen your concepts, and then you try to fix the timing. So if let's say that this paper takes you more than 1 hour 50 minutes, okay, no problem. At the beginning, focus on solidifying your concepts, and then later on you come towards time management. Okay, all right, so I'll see you in the next video then. Take care. Assalamu alaikum.